So you mentioned, the finance formulas are problematic, and I mean, finance, this section hasn't changed much at all from, the years and years I've been teaching it. And so you will have, and I put this, hopefully I've made this pretty clear in the discussion board too, but you will have the formulas. You don't have to memorize them. So don't stress about the memorization part, but just applying the right formula. And that's usually the biggest errors that I see in the finance section. So I just have this as a review that I give my my face-to-face class. I'm teaching at 10:30 right now, and we just went over this. So I thought I would throw up some of these questions. The thing about an exam is it's obviously, more like the quiz where it's it could be in a different order and you just don't know which formula to apply, right? So when you're going through the exercises, it's got like, oh, this is the section of, annuities. This is the section of loans. This is the section of compound interest. So it's pretty clear what formula to use, but then you get to the test and you start to go, oh my gosh, which formula, right? So this is what your test is going to look like as far as the last page goes. You'll have a section of finance formulas and a section of growth models, but they're not labeled. So as soon as you get the test, I would probably label them. So with the finance, this one is what I'd call like a one and done. Meaning you put money in once. You put money in once and then you leave it. Okay, so that can happen on some of the questions, but that doesn't happen as often as the other applications. So that would be something like your grandma passes away and she leaves you $5,000 and you just put it in the bank and you save it until retirement and you don't add anything to it. You don't take any money out. You just leave it alone for, a certain amount of time. The second formula, and so that's your most basic formula. The second formula here, I like to distinguish the next two formulas by the power. So if it has a positive power, then that means you're adding money to it, right? So it's got to be, this is exponential. So if it's got a positive power, that means it's going to be increasing at an exponential rate. So that means I'm growing it at an exponential rate, just like this one, but a little more complicated, obviously with an amount, the same amount every, K or N amount of times. Right? So that's your D. So that's the difference there is I'm going to be adding to the account every single generally month, right? In a retirement situation, I put in $100 a month or $500 a month. Okay. The third formula, again, you're going to focus on the negative there. That means that the principal is decreasing every month. This happens in two cases. This happens if I retire and I'm taking money out every single month, then the amount that I have in the account goes down every single month, right? And then the second case is anytime I have a loan, your principal is actually going down every month. Meaning if I went and I bought a car or I bought a house, so I buy a house for like $300,000, how much I owe next month is not $300,000, it's decreasing, right? So both of those cases use the exact same formula. Is anytime you see that negative there, that means that the principal amount or the loan amount is decreasing every single month. So is there questions about or clarification I could answer about those three formulas on finance? There's some information here. I was answering someone else's question, McKenna's question here. And particularly for the growth, because this one has an n-1 and this one has an n-1, those are considered recursive. And then because this one has, like this one has an n and this one has an n, that means that we can project further out. And so those are considered explicit. And of course, the first two, because I have a D, D means the difference in or change in time. So these would be linear. And then if I ever have an R, right? So D is the clue that it's linear and R is the clue that it's exponential.
Okay.
And then of course the crazy one down there is logistic, because it just fluctuates, right? So logistic, yeah, we'll go like it usually starts out exponential and then it just kind of hovers around, you know, like a carrying capacity.
Yeah.
Right. So that's why the formula, we can't project far out for logistic. We have to go year by year by year because it's going to change significantly each year based on the capacity. So,
okay. No, thank you. I appreciate that.
Yeah, those are hints as far as which formula to use. And again, like I said, you'll get this exact copy when you're given the test. And so I just write my little notes there, you know, whatever you need to do, and whatever, like I did with the finance formula. So yeah, so I kind of talked about those formulas, how to know what is what. So since the last thing we talked about was the growth models, I'll just jump into the growth models problems. So I have one up here from like a prior exam. So like Portland's population in 2007 was about 568,000, and it's been growing by 1.1% per year. As soon as you guys see a percent, you automatically should know, you know, that or narrow your options down. So which of these formulas should you be focused on as soon as you see a percent?
Is it one of the exponential ones?
Uh-huh. Yep. Because a percent is considered a rate, right? In fact, those two words are almost synonymous. You can call a rate a percent and a percent a rate. So you know that you have an R, which means that it's exponential. So you've got your test, you're looking on the back page and you're just like, okay, I know that it's these two formulas here. And recursive, remember the recursive is the n-1, and then the power one is going to be the explicit if it has an n in it. So the recursive formula, it's saying write a recursive formula. So I know now I'm going to use like, I'll see if I can change my color. Recursive, I'm going to use this one, right? Again, focusing on that n-1. So I should think about every time that recursive means it's an n-1. And sometimes people want to put like in my formula too much information. So with the formula, you always want to see the n. Don't replace the n at all. So I'm going to write, let me just write this down, just copying it over. So when I go back through and I read the information, I know that the 1.1 here is my R. And honestly, that's the only thing you're going to change when you write the formula down. You are not going to use the 568 because that's an initial, that 0 there means initial population, and my formula had no piece of 0. So you actually will not use that in the recursive formula. Okay, for the formula itself. Formula means no calculation. Don't do any math, just write the formula. So I'm going to leave p sub n, p sub n. I'm going to leave p sub n minus 1, n minus 1. And then I'll put 1 plus, and then I'll replace r with the 1.1%. Make sure you, and hopefully you guys have got this down because you've already gone through module 6, but change it to a decimal. Make sure you put in that 0, otherwise it'll be 11%, not 1.1%. So I'm going to put it in as 0.011. This would be completely acceptable as an answer on a test, or you can go ahead and do the addition, but I must see the n minus 1 on the left, on the right, and the n on the left. And so you can also have 1.011. Either of those are fine. I probably prefer the one where you actually do the addition, but I would still give you full points for the other one. Does that make sense on that? The first on A?
Yeah.
Okay. And then B, again, it's wanting you to find a formula, right? And so that means I still am going to have like the P sub n and an equal sign. And so now I know it's explicit. So that's this second one here, right? And so this time though, it has a P sub 0. So you can replace the P sub 0. So this is only in my explicit formula. Sorry about the handwriting there. But you would put 568. Personally, I would also add the 0 so I don't forget about them. So for the 1,000, so I'd put 568,000 and then times by 1 plus r, which I know now, I'm going to actually do just the addition, 1.011 and then to the n. So don't replace the n, right? N should be on both sides of the equation because it's a formula. But you could replace the P sub 0 and the R because those are kind of like constants, right? The rate doesn't change and the initial amount doesn't change. So that's all you would do for part B. And then for part C, that's where I'm projecting out into the future. So I would subtract the 2007 there to figure out how many years. Oh, not 2000. It's just going to be 11 years, right? And then just plug 11 into your explicit formula. So you're finding P of 11 now. So I'd have 568,000 times by 1.011 to the 11. And then just for the sake of time, we won't necessarily, I don't know that you guys need me to do that. I'm sure you should have that part down on the calculator. Do you know what you would want to do on D though? Any thoughts? Nothing from either of you guys. So this one, you would take the 1 million, and that's going to be your future population. So you would put it in on this side. You put 1 and then add your zeros. Oh, too many zeros. 1 million equals 568,000. And then times by 1.011 to the n. And that's now I'm trying to find n, right? Do you guys need a review of how to find n, or should we move on to applying the formulas on other problems?
So does that say that's NPN, right?
Yeah, sorry, there's the PN fell like into the formula. So this is the 1 million is my piece of n, which is why I replaced this left-hand side with 1 million.
Okay, perfect.
Right. So I just went up to B and then replaced piece of n. And then on this one, you would actually be needing to use the log function. So are you guys cool with using the log function? If not, I can show you again.
I'm good with it so far.
Okay. Stratton, what do you think?
Yeah, that's okay. That works for me too.
Okay. So yeah, you would just end up dividing and then using a log. I think number 6 is, I think, Paul, you might have asked a question like number 6.
Oh, I was just complaining about the blackberries questions.
Oh,
I
yeah,
hope
the
there's not going to be
blackberries.
one of those on there.
No, oh, absolutely not. That was like I said, that was a nasty coded question. It will not be like that. If I do a logistic question, it's going to be like this one that I've got. And so you would just go to your logistic formula. I've got it in a couple different places here, right? So you would then just plug in what it was initially, which was 60 plus, you know, R, which is 0.8 for the 80%, right? And then times by 1 minus 60 over 300, and then times by 60 if I have that formula right? And then when you get that answer, you plug that into this for all of the 60s, right? Whatever it happens to be.
Yeah, though it was just the blackberries that I really struggled on, and you know, with the loan financing and all that stuff. But the other one that I had a question about was the voting theory.
Oh, okay. Yeah, let's go back up to the voting theory. What can I answer for voting theory? Do you have a question from the homework or quiz, or do you want me to just make one up like I've got?
Mine was mostly about, oh, I can't remember the specific name of it, and I probably got notes on it in here somewhere. Let me find it.
Yeah, and while you're finding it, I mean, those are questions that, or like procedures that you do have to have memorized, right? Because we don't give you any hints. So like with board account, because I've got this one here, I think of BORDA, like boredom, it's tedious. And tedious means that we're gonna multiply every result, right? Or we're gonna count everything. So, and I can go through that if you want, but that's where you start with, you give 1 point for the last option, right? And then work your way up to give more points to the rankings.
Okay, I can't find my notes on it. I have like 5 different notebooks that I've been writing in for math for every module, so I'd have to really dig through my desk and find that notebook that has the voting theory in it.
So we've got, do you want me to go through board account, or do you feel like that was too quick of a review, or do you want me to?
The BORDA account I actually got, I think it was the plurality that I was
Plurality?
struggling with.
Okay.
Yeah.
So let's kind of look real quick at the plurality, and then I know I still want to jump to finance too and applying the formulas for you. But plurality with elimination, that's also called instant runoff voting. Basically, what we want to do is we've answered a couple questions first. You do want to make sure that you know what the majority is. And so in this case, you want to know how many people voted. So I've got 10, 14 people, right? So to have a majority, you need more than 50%. So I need 8, right? Does that make sense? No, I'm jumping through that quickly. So there were 14 people who voted. Just count up how many under each column, right? And then half of 14 is 7, but I need more than 50% to be considered a majority. So as soon as someone has 8 votes, they win. So that's part of plurality with elimination. You just keep going until someone has more than 50% of votes, which, by the way, just as a side, there are several cities who are now voting with plurality with elimination. So Sandy City. There's some cool stuff going on there. So I think the current mayor won with like, I don't know, 28% of the votes or something, because they just kept eliminating. They had like 8 candidates. So anyway, so back to this like logo though, what you're going to do is first look for the lowest number of first place votes. So we're looking on that first row, and A got 6, B got 4, C got 3, and D got 1. So you're going to first eliminate D. So what happens is D is eliminated from every column. And so everyone gets pushed up. So if you wrote this out, basically 6 people now, their ranking is still A, B, C. And 4 people, their ranking is B, C, D is eliminated. So A is the 3rd place. And then 3 people, their ranking goes from C to B to A. And then 1 person's ranking is now B to A to C. So everyone gets pushed up after you eliminate. And then you just do it again. So the next lowest first place is, let's see, A has 6. B now has 4 plus 1, right? Because they got 1 more with D being eliminated. And C has 3. So you're going to eliminate C, right? So C gets all removed from the columns. And then nobody has 8 yet. Remember, we keep looking at 8. And like as soon as someone has 8, they are the winner. So now 6 people, it's A and B. 4 people, it's B and A. 3 people, it's B and A. And 1 person, it's B and A. And so we're looking at first place votes again. So A has 6 and B has 4 and 3 and 1, because they get all of these, right? And so they have 8, and 8 is a majority. So we declare B the winner.
Okay, that makes a little bit more sense now. Thank you.
Yeah, no problem. Yeah, and then the pairwise or Copeland's method, you can see it written both ways. I believe your book generally refers to it as Copeland's method. That's where you go pair them off, and you go A versus B, A versus C, etc. In this case, yeah, we've got A, B, C, and D. So A versus D, B versus C, B versus D, and then C versus D, right? So you can create you can see this kind of a step model or whatever. And you're going to give 1 point to the winner. And a half a point if they tie. So like if I'm looking at A versus B, go back to you before I had erased all of these. A versus B, I'm looking here, A versus B, A versus B, and A versus B. And you want to know how many times is one ahead of the other. So A versus B, like A gets the 6 people over in the first column. B gets the 4 people in the second column. B gets the 3 people in the third column, and also the 1 person in the last column. So therefore, B gets 1 point, and A gets no points. So it's like all or none, or we split the vote. And then you would do the same thing with A versus C, just who's on top more often, right? And then they get the point. And then you just add them all up. So like B has 1 point there. If B had 1 point here, they would get 2. You know, if they had 0 points here, they'd have a total of 2 here or something. So these are the pairwise numbers or answers are going to be really low, right? Because you can't win more than 3 times. So all of them are going to be less than, 3 or less. Any clarification on that?
No, I think that's probably one of my favorite ones. It just is straightforward. So
Good.
Nope, no questions. Thank you.
Cool. Okay. Well, let's jump to the finance then. And even if we don't go through like all of the math, I do want to make sure that you know the formula to use. So let's take, again, these are from like a prior test. So if I said you deposit $2,000 in an account that earns 7% interest compounded monthly. So would I be using formula, let's call this 1, 2, or 3? Any thoughts on which formula for question 8?
I guess 2.
And that was Stratton. What do you think, Paul? Would you use 2 as well? Oh, you're still on mute.
I would say option 1.
Why?
Well, the reason why I would use option 1 is that you're starting with $2,000 and you're wanting to do it for over 10 years. With that one, you could do the simple formula and figure it out by using the NK at the top as your 7% times, the 10 years, because that's what I've been doing with most of mine, is just using a simple formula that's been given, and I've been figuring it out.
Okay. Yeah, so this one actually is the first formula. And the reason why, they both, the first and the second, both have the NK. So both of you are right to use the formula with the positive power. But the difference on this one is this is essentially the one and done, right? Like I'm only depositing $2,000. If it said $2,000 a month, then you would use 2. But it's not like a monthly deposit. It's just one deposit, leave it alone. So you would end up using formula 1. So, and then this would be, what is the 2,000? Is that piece of N or piece of 0? What would you guys guess?
Piece of 0, right? Because it's the initial. The initial.
Exactly. Yep. So you're just going to find the amount in so many years. Specifically, you're actually finding P sub 10 because you're finding it after 10 years. So your N is 10. So that P sub 10 is going to be my 2000 times by 1 plus 0.07 over 12 to the 12 times 10, right? And I do suggest you do that multiplication before you throw anything in your calculator, just so that you have a single power there. So you would end up with, 240. Just remember you're making 200. They're giving you interest 240 times, right? 10 years. Nope, sorry, I did my math wrong. I was thinking 20 years. It would be 120, right? 12 times 10. So, and then you just multiply it. I'm using your calculator. You guys starting to feel pretty comfortable using your calculator? It definitely takes a little bit of work to get that system down, especially with formulas 2 and 3.
Yeah, for sure.
Yeah, I've been trying. I've been trying to get the closed and open parentheses done right as I'm working on the calculator. So
Yeah.
I think I've ended up with more syntax errors than this poor calculator has figured out.
Yeah, I don't, even though, I don't know, I'm a math professor and stuff, maybe that's why I don't do this, but I actually like to do the steps one at a time instead of using parentheses on my calculator. So, and I would, even though the formulas here don't have it, I do suggest making sure you always put that bottom one in parentheses. Always, always, always. So throw them on there, even though they won't be around that bottom fraction on your formula sheet. So
this might be a stupid question, but for those ones like number 2 and 3,
yeah.
Oh, can we actually do next one of those examples? Just the whole division of the R and K.
Yeah.
I just want to see how that is laid out so I don't screw that up when I do it.
Sure. So let's look at number 9 and 10 and decide what formula we're going to use on each of those. So number 9, you can afford a $400 a month car payment, and you've got a 5-year loan at 5% interest. So how big of a loan can you afford? So the question then is which formula should I use? 1, 2, or 3?
2.
Yeah, I agree because it's adding to it every month.
Okay, and this is where, unfortunately, you guys are both wrong.
Oh, man.
I know, this is why you're here, right? So because it's a loan, you should use number 3. And I know that can be a little bit tricky because I know we're thinking you're adding to it every month, but what you're actually doing is they're giving you a lump sum of money, right? And you're decreasing how much you owe every single month, right? When you go to buy a car, essentially they're handing you the cash and it's decreasing every single month how much you owe them because you're paying it off every single month, right? Just a little bit at a time. So, yep, make sure when you get that sheet, that formula sheet, just look for the negative and write down these 2 cases. If you see a loan, I want you to use the negative. Okay. Or if I say you're retiring, I should say that a little more specifically, at retirement, right? Or after you retire, that's the other time you use it.
Are the formulas going to be in order like this on the test?
Yeah,
okay.
This is the exact same order. Unless I really want to be cruel.
I'm trying to be able to memorize what goes where. That will help. So I appreciate that.
Yeah. So I won't be that cruel. I've actually already typed out the test. So this is the order. You'll see it. So loan, negative amount, right? Or a negative power. And then, of course, in this case, what would you use for the 400? Where does that go? What variable? That's going to be your D, right? The 5 is your N. The 5% you're going to put in as 0.05 for your R. And then do you know K?
K is going to be, sorry, I have to really squint down at my screen.
Oh, sorry, I can even make
No,
it
it's
bigger
fine.
here.
No, it's fine. You don't have to. I can zoom in and out also.
Okay, great.
D is what we're figuring. No, not D, but K is the, because it's 5 years, so it's going to be a 12 because you have 12 monthly payments.
Yep, that's your clue right there, because the month, right? Because you're paying it monthly, which is, the most common way to pay off things is we use monthly payments. So we almost always use pay as 12. The other thing I want to point out why this is also number 3 is because it's saying how big of a loan, but that means my initial amount too, right? So you want to find P sub 0. So that means I'm going to find this P sub 0 over here, and everything that you're given is on the right-hand side. That's another reason, to help you see that you need to use that third formula. And then, of course, I'm going to just plug it in. I'll have 400 times by 1 minus 1 plus 0.05 over 12 to the negative 5 times 12 all over, and then again, I put in 0.05 over 12 in parentheses. First thing that I would do is change that power to be a negative 60. So take my 5 times by 12. And then Stratton, you said you wanted to see this with the R and K. Do you want me to step through the calculator side, or is this enough?
I'm actually trying it right now just to see if
And I will try it real quick here too, or at least look at my answer to see if you have an answer.
I do. I'm scared it's wrong, but it's 21,196.28.
You got it. Nice.
Good. Okay.
Yep. Yeah, so you could afford a $21,000 car, right?
Okay.
Yeah.
That makes sense.
And I'll tell you on the test too, if you can at least write down this so that I know what did you try to punch into your calculator. So let's say that you wrote this, the formula with all of the variables in it, and then you happen to punch it through incorrectly and got some answer like 5,672, right? I'll still give you like, if this question was worth 6 points, I'd probably give you like 4 out of 6 points because I know like you at least knew the right formula to use. Everything, like all of your variables were replaced correctly. If you can use the right formula and replace your variables correctly, I'll give you most of the points for it.
Yeah, I appreciate that. I noticed that in the last test, it's not all or nothing. So I appreciate that, giving us a little lead, a little bit of air.
Right. Yeah. But you should always look at your answer too and make sure it makes sense. A $5,000 car would be kind of a low, amount if you're paying $400 a month for 5 years.
For sure.
Yeah. So, let's just double check which formula to use for the next one. So you have 5,000 saved for retirement and your account earns 6%. How much will you be able to pull out each month if you want to take withdrawals for 20 years? 1, 2, or 3?
Since I already know I messed up on the last question and picked the wrong option, I'm actually going to pick option 3 this time because it's a retirement question.
That's what I saw was the retirement word. So I'm going to go with the third
Okay.
one.
You're right. It is number 3, but I don't want you to focus on the word retirement
Okay.
because this one can also be retirement, the second one, but it would be save for retirement.
But it's also because of the negative, because you're withdrawing out of it.
Perfect. Yeah. So that withdraw is the one that makes it number 3, like, or even pulling out. Those both indicate, okay, use the third formula. And then where would you put the 500,000 in that third formula?
That would be the PO,
Mm-hmm.
because you want to figure out how much you can pull out every month. So you're going to be, so D, which is what you're figuring out. So you're going to do D and then the parentheses 1 minus 1 parentheses 1 plus, and then it's going to be 0.06 over 12 because it's a monthly. And is it monthly?
It
Yep,
is.
monthly.
Yep, monthly.
And then you're going to want to figure out for 20 years. So it's going to be 20 times 12, but it's going to be a negative.
Mm-hmm.
See, I figured most of that out today.
Yeah, and this is the part that I think, again, like you guys are just starting this section, and I know I'm holding the session on Tuesday, and I don't think the chapter's due until Thursday. So I know there's going to be people who watch this later because, or haven't done this yet. Yeah, so that would be the formula that you use. Honestly, what I tend to do, and I can't remember, the videos do this different than I do, if I remember correctly, but I will do all this in my calculator. And then I take 5,000 divided by this crazy answer. And
Yeah,
that
the way I've been doing it is that I'll figure out the top part first. So from D all
Mhm.
the way across. And then once I
Yep.
have that answer, then I'll divide it by the bottom part itself.
Yeah,
And then
so yep. So step 2, divide it by 0.06 over 12, right? But
Mhm.
I'm going to emphasize this to students who may watch this later. Please, if you divide by, you hit like divide by 0.06, divide by 12, it will be wrong. You must use parentheses around the 0.06 divided by 12. Otherwise, it's dividing by 0.06 and then taking that answer and dividing it by 12. It's an order of operations thing. So
Yeah, that's the one nice thing about the calculator, the 36X Pro, is that you have the little fraction button that you can actually make it into a fraction and still do it that way.
yeah, you're lucky you've got the Pro, and I think that's something we suggested getting,
Mhm.
right? Because it is nice to be able to see it typed out in a cleaner fashion. I don't even have the Pro, but it is easier for students if they do.
Yeah, but that's how I've been doing the math, and so that it makes it easier on me so that I can understand it easier.
Mm-hmm. Yep. Yeah, I think that's a good approach. What do you guys think? You want to try a couple others? How you feeling?
I'm feeling good. I actually, you helped me out understand a lot more of this stuff, and it's easier now that I got some outside help because I've been struggling with it, and my wife has been frustrated with me because I've been struggling. But now that I can see how it's been explained and how easier it is, then I think I can handle it now.
Yeah,
Yeah,
I
and
have
I
to
think
tell you, it's much easier to take this class in person.
I was just gonna say I was doing all online because I'm working, but yeah, I know for my next math classes they're going to be in person because
So number 11, I want to point this one out because it's also a retirement question. So you want to have $500,000 for retirement in 20 years. Which formula would you use? And I know I've got my growth models over here, but we could go back up there to my messy. So if you are saving for retirement, you want $500,000 at retirement in 20 years from now, 1, 2, or 3.
I'm saying 2.
Stratton, what do you think?
I mean, I feel like that's right, but I'm trying to process in my brain why that's right.
Yeah, it is right. You would use 2. You would you want to have 500,000, so that's an eventual amount, and so that would be your piece of N, right? And you're trying to figure out how much to deposit. But the other thing is, this is, again, it's a deposit that you're adding to the account, meaning you are growing your account, and so that deposit means that you should look for a positive power. Right? We're growing it. We're not taking money out of it. We're growing it. Keep adding to those discussion boards. I'd like to see. I think we've started to use those more and more these last couple of modules, but feel free to keep adding them there. And I'm happy to answer any questions you guys have.